Question number 3. So again, every question they want to give application of the real life field. That is what we like most. It is a free response question, 2021, question number 3. A company designs spinning toys using the family of functions y is equal to, so they're designing some toys using some function y is equal to cx into root of 4 minus x square, where c is a positive constant. The figure above shows the region in the first quadrant bounded by the x-axis, and the graph of y is equal to cx into root of 4 minus x square. So they also gave us the graph. Very happy. For some C, each spinning toy is in the shape of a solid generated when such a region is revolved around the x-axis. So they're telling that some volume is formed when the toy is rotated, when this function is rotated about the x-axis, and the units for x and y-axis are inches. So under these conditions, they're asking, find the area of the region in the first quadrant bounded by the x-axis. So I want to know what is the area bounded by the x-axis, this x-axis, and this function. So indirectly, I want to find this function, area between the y-axis and this function. And they also give the value of C as 6. So we know area under the curve is, if this is A, this coordinate is B, integral of A to B. If this function is f of x minus 0, which is f of x into dx. That is my area that is my answer for the first question. So let us simplify. So other thing that I don't know here is B. I know A is starting from 0. I don't know B, but I know when at B, y value is 0. So I'll equate y to 0 and I'll try to find B. So 0 is equal to cx into root of 4 minus x square. So c is a positive constant. So 0 by c is 0. So x should be 0, or square root of 4 minus x square should be 0. So x is equal to plus or minus 2. But x lies in the positive x direction. So the value of b should be 2. So integral of 0 to 2, f of x is given to me as the value of c is 6x into square root of 4 minus x square into dx. So this is my final function. So 6x into square root of 4 minus x square into dx is my function. So let us see how to find this integration. 6 comes out. Integral of 0 to 2 x into square root of 4 minus x square into dx. See how simple is this entire question is. First part is just finding the area under the curve. So integral of a to b f of x into dx. I can see x, I can see x square here. So you take 4 minus x square as t. So take 4 minus x square as t. Minus 2x into dx is dt. So dx, x dx can be written as minus dt by 2. So x dx can be written as minus dt by 2. 6 into, the limits also changes. So when x is equal to 0, t is 4. So integral of, when x is equal to 0, these are the limits for x. Or you can finally convert in terms of x. If you don't want to change limits, why to again waste my time? I'll convert everything into x again. So for right now, let me put. So I'm putting it as, I'm not putting the limits because finally I want to convert into x again. Integral of t, x into dx can be written as minus dt by 2. So this goes 3 times. Minus 3 times integral of root t into dt. So if you want to put limits, you'll understand. Put x is equal to 0, y is 4. So put x is equal to 2. Put x is equal to 2, this is 0. So I'm reversing the limits. So 3 times integral of 0 to 4 root t dt is my final limit. So if I integrate this, I get an answer. So 3 into t power 1 by 2 is t power 3 by 2 by 3 by 2. This goes to the numerator. 3 into 2 by 3 into t power 3 by 2, limits are 0 to 4. So when it is 0, 0. So when I put 2, 4, 3 into 2 by 3 into 4 can be written as 2 square. So 2 and 2 will cancel, so it is 2 cube, which is 8. 3 will get cancelled, so 2 into 8 is 16. So your final answer should be 16 square units. You should do everything. You think, no, I know integration, you don't know how to plug in the values, you make mistakes here. There are many mistakes you do. You need to do everything step by step, then only you are going to get to the answer. If not, you'll never get the answer. If possible, I'll do in the Wattpad. If possible, yeah. If it allows me to write, I'll do it here. I'll erase this and I'll do it once again for you. So my function is, I have a function here. This is like this, 0. This my function is y is equal to, what is my function? Y is equal to cx into root of 1 minus cx into 4, 0, right? Yeah, cx into root of 4 minus x square. This is my function. I need to find this area. So first I need to find this value. So this value should be definitely to equate this to 0. Cx into root of 4 minus x square is 0. This becomes 0 when x is equal to 0. This becomes 0 when x is equal to 2. At 2 points, it becomes 0. At -2 also, but this is positive x-axis, so I'll take it as 2. So integral of 0 to 2, c value given as x. So 6 into root of 4 minus x square into dx. So take 4 minus x square as t. So minus 2x into dx is dt, or x dx is minus dt by 2. So 6 into minus, this is dt by 2. So into 1 by 2 into dt. This is root t. So if I take the limits, when x is equal to 0, t is 4. When x is equal to 2, t is 0. So my function becomes minus 3 integral of 4 to 0 root t dt. So now I'll interchange the limits. So it can be written as 3 into integral of 0 to 4 root t dt, t into t power 3 by 2 by 3 by 2 integral of 0 to 4. This becomes 2 by 3. So 2 into t power 3 by 2, 4 to 0. 2 into 4 power 3 by 2 minus 0 power 3 by 2. 2 into 4 power 3 by 2 is 8, which is 16 square units. You need to have so much clarity. Many of them get stuck with plugging in the, changing the variables, nothing. Some will get stuck with even identifying this step. If you get stuck in even in the first step, no one can do anything. So area under the curve is integral of a to b, f of x, f of b minus f of a here. So upper curve minus lower curve. So lower curve is 0. So y into dx. So f of x into dx. Identifying then a and b, then you're doing the integration of the function. So all steps are very clear. So this is what is the answer for the part A. Now, if I see part B, I'm just erasing all the things. Yeah. Now part B. If you see part B, they had given that it is known that y is equal to s. They gave the function y. Once they gave the function y, what is y? Cx into root of 4 minus x square into dx. And they gave the derivative of this function. UV rule they applied and they did the derivative. For a particular spinning toy, the radius of the largest cross-sectional circular slice is 1.2 inches. The radius of the largest cross-sectional circular slice is 1.2 inches. What is the value of C for the spinning toy? Means, so if you read the question, the figure above shows the region of the boundary with x-axis and the graph of each spinning toy is generated when such a region is revolved. So they gave me the value of y, the particular spinning toy, the radius of the largest cross-sectional slice is 1.2 inches. So they're saying this is 1.2 inches largest. So if y is equal to the largest value possible here is 1.2, what is the value for what is the value of the c they are asking? So we clearly know the minimum or the maximum for a given function occurs at the critical points. So first you try to do the derivative of this function. So if you try to do the derivative of this function, they gave the derivative of the function also. So we know critical points occurs when the derivative is equal to 0 or does not define. So put f dash x equal to 0. We put x is equal to 0. C into 4 minus 2x square by something should be 0. So 4 minus 2x square should be 0. 2x square is 4. 2x square is 4. So x square is 2. So x is plus or minus root 2. Now this x is clearly it is in the positive direction, so it can't be the negative root 2. So the value of x should be root 2. So when x is equal to root 2, this is one of the critical point. Here the maximum or the minimum occurs. So now put x is equal to root 2 in the function, and they give the maximum value of the spinning cross-sectional area, cross-sectional slice, which is 1.2. So the y value is 1.2. So there is only one critical point. So now I'm directly plugging into the function because the maximum or the minimum occurs since there is only one critical point. So I'll try to plug in the value of root 2 here. So 1.2 is equal to c into root 2 into 4 minus root 2 whole square, which is 4 minus 2. 1.2 is equal to c into root 2 into root 2. 1.2 is equal to 2c, or c is equal to 0.6. So simple. So the value of c for which the radius of the largest cross sectional is 1.2 is, it should be 0.6. So what is the concept that I need to apply here? Okay, the maximum or the minimum occurs at the critical points. So critical points are the points where the function is equal to 0 or undefined. So for example, if we take it as undefined x is equal to 2, I don't get any value for y. So I'm not taking. So the only positive value that you're going to get here is x is equal to root 2. So put x is equal to root 2 in the function and y is equal to 1.2, because since you have only one critical point, you are not required to do anything else. The maximum occurs at that point. So put x is equal to root 2, find the value of c. So the value of c for which the maximum radius of the cross sectional occurs is 1.2 inches. So 1.2 should be your answer. Yeah. So since you said largest, we need to take the largest. The minimum or the maximum should be occurring at the critical point. So critical point is this point, plus or minus root 2. But we take only root 2 because it is in our limit. Yeah. Now, at this, when x is equal to root 2, the maximum occurs. And I know the maximum value. So I'm plugging in so that I'll get the value of c. The value of c is 0.6, which is perfectly clear. Now, if I see part C, what they're given in the part C, for another spinning toy, the volume is 2 pi cubic inches. What is the value of C for this spinning toy? So I'm getting the volume by rotating, revolving this around my x-axis. So this is the volume that we are going to get. So volume is pi into integral of a to b pi r square into dx. So I'll integrate all these volumes from a to b. So pi into a to b, all these slices I'll integrate. All these slices. Integral of a to b, f of x whole square, that is y square into dx. This is my volume formula. So now I know a and I know b. So volume is equal to integral of 0 to 2, pi is also there, f of x is also there. F of x is cx into root of 4 minus x square whole square into dx. Volume is equal to integral of 0 to 2 pi into cx into root of 4 minus x square into dx. So I'll try to find the value. So pi comes out, but they give volume as 2 pi. So 2 pi is equal to pi into integral of 0 to 2 c square x square 4 minus x square into dx. Pi gets cancelled, therefore 2 is equal to c square is a constant, so it can come out integral of 0 to 2 x square into 4 is 4x square, x square into x square is x power 4, so 4x square minus x power 4 integral of 0 to 2 into dx. Therefore 2 is equal to c square into 4 into x square is 4 into x cube by 3, x power 4 is x power 5 by 5 integral of 0 to 2. 2 into c square into 4 into 8, 32 by 3 minus 32 by 5. So 2 is equal to 32 c square into 5 minus 3, 2 by 15, 64, 2 gets cancelled. C square is 15 by 32. C is equal to root of 15 by 30. So whatever is the answer, that should be the answer. We just need to know this rotating, so circular cross sections. So combination of all this will give me answer. So pi into integral of a to b f of x whole square into dx. Then simple calculation. So this question is so simple, direct and straightforward. You just need to know how to find area, how to just basic application of integrations. Part B is basic application of the differentiation. The maximum occurs at the critical point. So we need to do that using the critical point concept. Okay, so such questions you should never leave in the exam. Whenever you get a question, you should be so lucky, should be just happily able to solve that question. Okay, yeah, I'll stop.